Alright, this is Mr. T, and I'm going to be, I have some example problems here that I'm going to do for my Algebra 1 class. They are problems from 10.2, which is simplifying radical expressions, 10.3, operations with radical expressions, and 10.4, radical equations. So we're going to be solving radical equations. Alright, so let's start with 10.2 first. Alright, and the first problem we have is 7 times the square root of 63m cubed p. Alright, so the first thing we want to do is I like to simplify the number under the square root first. So we have a 7 on the outside. Alright, and then we want to see what 63 can break down to. So we have 9 and 7 and then 3 and 3. Alright, so we can rewrite this as 3 times the square root of 7. Alright, and you want to remember that you have the number on the outside. So we're going to multiply 7 and 3. So we're going to have 21. Alright, and then leave a little bit of space because something else is going to be getting pulled out. And then you have a 7 on the inside. Now, when you look at m cubed, you can rewrite m cubed as m squared times m. Alright, and we know m squared is a perfect square. So the square root of m squared is just going to be m. So you can pull that out. You leave an m on the inside, and then the p just stays the same as well. So your answer is just 21m times the square root of 7mp. Alright, and then this next problem, we have to rationalize because you can't have a square root in the denominator. So we want to multiply top and bottom by square root of 8 over square root of 8. And then on top, we get the square root of 8h cubed over 8. Alright? Now, this radical can be simplified. Alright? When you break down 8, alright, it comes to 4 and 2, 2 and 2. Alright? So it ends up being 2 times the square root of 2. So we have 2 times the square root of 2. And then h cubed can be simplified as well. Same thing over here, what happened with the m's, m squared times m. Here you could have h squared times h, so you can pull out an h and leave an h there, all over 8. And again, you could simplify a little more. You get h times the square root of 2h over 4, because the 2 reduces with the 8. Alright, so this is going to end up being your final answer. And then we have one more problem from 10.2, which we have to multiply the top and the bottom by the conjugate. Alright, so we're multiplying by the square root of 7 plus square root of 2. Square root of 7 plus square root of 2, top and bottom. You're going to distribute the 3. So the next step is going to be 3 times the square root of 7 plus 3 times the square root of 2, all over 7 minus 2. Alright, and then you just get 3 times the square root of 7 plus 3 times the square root of 2, all over 5. Alright, and that's it. Now we don't have any radicals in our denominator, so we are good to go. Alright, and then we're going to go to 10.3, operations with radical expressions. Alright, so we have the first one, we have the square root of 180. So let's simplify that first. So let's see, what are two good factors of 180? Let's go 18 and 10. This breaks down to 5 and 2. This breaks down to 9 and 2. 9 breaks down to 3 and 3. So I'm pulling out a 3, and I'm also pulling out a 2. Alright, so we have 6 times the square root of 5. Alright, so 180, the square root of 180 breaks down to 6 times the square root of 5, minus 5 times the square root of 5. Alright, let's see how 20 breaks down. We have 5 and 4, 2 and 2, so plus 2 times the square root of 5. And now we can combine like terms. Alright, so 6 minus 5 is 1 plus 2, so our answer is 3 times the square root of 5. Alright. Now the next problem, we're multiplying multiple terms. Alright, so we're going to have to FOIL this. So if we do the first terms, we have square root of 6 times 4 square root of 3, which is going to be 4 square root of 18. Then the outside terms, minus square root of 60, because you have square root of 6 times negative square root of 10. Inside terms, so we have plus 16 times the square root of 15. And then the last terms, we're going to have, that's going to be a minus 4 times the square root of 50. Alright, now we're going to have to simplify some of these. So 18 breaks down to 3 times the square root of 2. Alright, because you break it down to 9 and 2, and then the 9 is a perfect square, so you pull the 3 out. So this is going to be 12 times the square root of 2. 60 breaks down. We have 10 and 6, 3 and 2, 5 and 2. So we could pull out a 2, and we're left with 15 on the inside. 15 can't be broken down anymore, so we have plus 16 times the square root of 15. And then we have minus 4 times square root of 50. So square root of 50, we have 25 and 2. And so we're going to be able to pull out a 5. And remember, you need to multiply it by the 4. So you're pulling out the 5 times 4 is 20 times the square root of 2. Now I have like terms here and like terms here. Alright, so 12 square root of 2 minus 20 square root of 2 is negative 8 square root of 2. And then negative 2 square root of 15 plus 16 square root of 15 is 14 square root of 15. And that's your answer. Alright, perfect. And now I have one more question I'm going to do from 10.4, which is radical equation. So we're actually going to be solving for k. Alright, so when you have a square root with multiple terms under it, you want to get that by itself on one of the sides of the equal sign. So this way you're able to go and square everything. Alright, and then once you do that, you can get rid of the square root. You have 17 minus k equals, you have to FOIL this. You cannot distribute that exponent. This is equal to k minus 5 times k minus 5. And when you FOIL that, you get k squared minus 10k plus 25. Alright, whenever you get a quadratic, you want to set it equal to 0. So we're going to subtract 17 on both sides. And we're going to add k on both sides. So we get 0 equals k squared minus 9k, and then this is going to be plus 8. Plus 8. Alright, so what we want to look at is two factors of positive 8 that add to negative 9, because since this is a quadratic, we can factor it, right? It's factorable. So we can rewrite this as